that will also not happen. So let me start by saying this. The first ICCC was in 2010 in Lisbon. It was organized by Milka over there. And Dan, I think, Dan doesn't remember. It was a long time ago. Oh, Ben, apparently you were the program chair. Doesn't matter. Don't go into details. Then we tried to organize the conference in Coimbra sometime in the past. COVID happened and we had to do it online. So finally, after all these years, ICCC is finally done in Coimbra, and it is a great pleasure to welcome you all. This is Coimbra, as you may have known. As you may have noticed, this is a very old university. The university was established in the 13th century. So, yeah, Dan was here, but he doesn't remember. Anyway, so this is Patio das Escolas. It's one of the oldest parts of the university. This building is not from the 13th century, okay? So this building is actually from, it was inaugurated in 69. And believe it or not, Portugal at the time was under a dictatorship, and this is the president, Américo Tomar, inaugurating this building in this exact room. Okay, so this is why the room has the name of the 17th of April. It was here that the department was inaugurated. They are not so happy, as you can see. Usually dictators are not happy people. I'm not really sure how, but you can see he's not happy. And in this case, he's not happy. Oh, by the way, this was the atmosphere before the inauguration. So nice people on horses doing what the political police usually does. So they were not happy because the president of the academic association sitting over there asked to use the word in the name of the students. In fact, he put it in a very interesting way. And the president said he could speak, but only after the Minister of Education has done his intervention. Well, the Minister of Education sitting here with Dan on the side did his short speech, and then they were slightly scared and they basically ran away. And outside what was happening in those same stairs, so there is maybe 2-3 hours difference between the two pictures. This was what was happening. And this is the beginning of the academic crisis that eventually led into a coup d'etat and the overthrow of the dictatorship. There are many stories in between. The guy that asks for, let me go one slide back. The guy that asked to use the word was arrested by the political police later that night. And there is quite some steps in between, but the point being 5 years later, we finally had a democracy. So this is just my small introduction that I do more or less every time I do a presentation in this room. It's not from the 13th century, but is a room that is still very important to us. And it's a pleasure to have you here. I hope you really enjoyed the conference. And I did absolutely nothing. I'm the general chair. I did nothing. So if anything goes wrong, that's my fault. I should have worked more. If whatever happens that you like, that's the work of the local organizers, of the program committee, of the reviewers, of the authors, and so on. And that's all I have to say. Thanks a lot.
The dictator has spoken, and now it's time for us others to say something. On behalf of the program chairs, I'd like to welcome you all to the 17th conference on computational creativity. So here are my colleagues Hugo and Anna, and I'm Hannu. It's been great pleasure to work on the program. Most of you have been members of the program committee and have been contributing to the selection of the papers. And of course, even more of you are authors and soon to be presenters of these papers. Couple of statistics. I used to work on data mining, so I like numbers and statistics. So here are a couple of those for you. The program will consist of 27 contributed full papers presented as talks here, starting right after this opening session. 38 short papers, 8 of which will be presented with short talks, and 30 as posters, and 10 of those additionally as demos. We have a great pleasure of having 2 invited keynote speakers. Jennifer Jacobs from the University of California, Santa Barbara, will give her talk tomorrow on materials and machines, how the physical world can inform computational tools for creative production. And then on Thursday, we will have Leonel Moura, a Portuguese artist, giving a talk titled Sapiens AI, the New Condition. So stay tuned. And many of you already attended the program that we had before the main conference starting yesterday, and still today we had in total 5 workshops. We had an early career symposium and a celebration of Margaret Bowden that was transmitted to us over video just a couple of hours ago. Some more numbers. We received in total 106 submissions for the full paper track, 33 out of which turned out to be incomplete, out of scope, completely wrongly formatted, and desk rejected. So in the end, we have 73 valid submissions, out of which we accepted, based on the hard work of the program committee, 28 papers, so 38% acceptance rate. And you see the numbers for the short track here. 75 valid submissions, out of which 38 or 51% were accepted. And in the spirit of the conference, which is to bring together people working on creativity, computational creativity, from different viewpoints, with different backgrounds, there's a great variation in the types of papers that we have. So those of you who have been before to ICCC know that there are many different kinds of contributions and papers. For full papers, here are the statistics. We have cultural application papers, position papers, study papers, system or resource descriptions, and technical papers. These are classified by the types of papers we had in the call for papers and in the submission form. And for short papers, we have even more variations, since part of the function of the short papers is to make the discussion livelier. You can see the broad range of different kinds of topics, approaches, attitudes towards creativity, computational creativity. Then a word about you. We have 84 registrations, 29 out of which are students, and 49 regular ones, and 3 only for workshops and tutorials. And we are extremely happy to have participants from 28 different countries. Here are the biggest ones in terms of numbers of participants. United States, nice to have people coming from another continent, Portugal, obviously, and then European countries, also Australia. So really happy to have a global conference, so to say. And the last item on our behalf is to just tell you in advance that we will give out best paper awards. They will be handed over on the conference dinner. The award committee, consisting of the 3 of us, has selected best papers, best student paper, best short paper, but it's up to you to vote for the best poster. So please visit the posters tomorrow and Thursday and vote with your ballot. It's not green, it's blue actually. So use your ballot to vote for the best poster, and the winner will be awarded over the dinner on Thursday evening as well. So that's all on our behalf. Thank you and warmly welcome. And now we'll hand over to the local chairs.
Thank you, Arno.
Good afternoon, everyone. I'm Pedro Martins, one of the local co-chairs of ICCC'26. The other local co-chair is João Cunha. And we are here to talk about the social program, also known as the best part of the conference. Okay, right after the paper session, the first paper session, we'll have the welcome reception. And it will take place in the botanical garden next to the greenhouse. That's the greenhouse. It's a 3-minute walk from here. If you're slow, it's a 10-minute walk. We can meet outside in the lobby right after the paper session. So that's the first event. So tomorrow we'll have a guided tour of the University of Coimbra. The University of Coimbra was founded in 1290, just like Nozal said. I think it's the 7th oldest university in the world in continuous operation. And it has been listed as a UNESCO World Heritage Site since 2013, June 2013. So that's tomorrow. We'll visit the university. That's the Royal Palace. My PhD examination took place here. Scary, I have to tell you. And the meeting point will be the Department of Mathematics, the main entrance at 6:30. On Thursday, we'll have the conference dinner at Quinta do Encontro. Quinta do Encontro. It's a winery located in Anadia, and it's a 40-minute drive. So we'll take a bus from here. And the meeting point will be the Department of Physics, the main entrance at 6:30. And you received an email last week. I hope you have filled out the form. If you haven't, please do so. If you have restrictions, please do so, okay? I don't want vegans to get beef, okay? Okay. For Friday, we have a visit to Anzero, to the main exhibition of Anzero. Anzero is a contemporary art biennale that takes place in Coimbra. It's great, I have to tell you. So that's the plan for Friday after the conference. Okay, it's a 30-minute walk, and the plan is to walk at 2:30. I know it will be hot. Probably we can get a bus, but I'm not sure if we will get a bus. So the initial plan is to walk from here to Santa Clara Nova Monastery. You're right. You're right. But you're Spanish. You're used to. Okay, so that's the plan, and the meeting point will be here, the main entrance of the Department of Mathematics. So that's it. Once again, welcome. It's a pleasure to have you here, and join our Discord server. Okay, you want to say something?
Yeah. I have just two things to say. First, careful with the stairs. The stairs are very slippery. We already had an accident. So please be careful. And second thing is, we have a special request from a participant, Claudia. She's there. She's doing a demo, and she asked if everyone could take a piece of paper and draw the face of a robot. Okay? And once you do that, you can leave your sheet of paper in the registration desk. Okay, please do it so now or latest tomorrow morning. Okay. And regarding the visit to the university, I just want to make a small correction. We are going to see the old sites. We are going to see the old monastery. That image that you saw where the PhD defense of Pedro took place, if you want to see that room and a very, very nice library, you should book it on your own, okay? You should try to do it. I advise you to do it, okay? You want to say something? Okay. So you have two poster sessions, okay? You have one poster session tomorrow and one poster session on Thursday. You can vote on Thursday, okay? There will be a ballot for you to put the voting pieces of paper, and do it so on Thursday so that you can see the two sets of posters, okay? If there is any more questions, please let us know. Okay, so you know where you had
Together. They're not.
you know where you had lunch, right? It's between two buildings. So it's the one that is closer to this department. Okay, if you go out in the other one. Okay, so it's the other one. I'm sorry. We correct each other. It's how it works. Any more questions? Exactly. So Hugo is stressing that you should really, really book your trip to the university. There's a library, very, very nice, with bats that eat moths so that they don't eat the books. Okay. It's
the most beautiful library in the world. That's what I was saying.
okay. So that's all we had to say. Thank you and welcome. We hope that you enjoyed the conference.
So thank you also from my part. And I have the actual pleasure of opening the scientific program of this conference. And I would like to invite Dan Ventura to give the first talk. And it is going to be on a topic that I think everyone here will find very interesting. Dan is talking about LLMs, or foundational models in general, and how do we interpret them as creative, or do we?
Did I miss a joke? I missed the joke. Dang it. That would be great. I'll ignore you, but it would be good to hear it. I'll try to pay attention to the time. But this doesn't count right here. This is not count.
I'm starting the time when you start.
Okay. We're good now? Okay. Hi, everybody. My name is Dan Ventura, and as Penuzal said, I was here when this place was founded, but I haven't been back since, so it's great to be back here. This is actually my first visit to Coimbra. I wasn't here in 1290. But I'm really delighted to be here. It's a beautiful town, beautiful university. And what I want to talk today about is, as Anna said, a look at modern foundation models through the lens of some process-centric frameworks that were developed by this community over the last decade or decade and a half. And we only get 12 minutes, so it's going to be impossible for me to say what I really need to say about this. I'm just going to give you a little flavor. In fact, even in the 8 pages of my paper, I didn't have nearly enough room to say everything I wanted to say. So I probably maybe need to write a bigger paper about this, but I think it's interesting and important to do. This is my best abstraction of what modern generative AI does. And I think it is abstract enough and general enough that it covers pretty much everything out there right now. And we can quibble about whether or not that's true or how exactly it covers, but I feel pretty good about that. There's 2 major pieces here. One of them is generation and one of them is training. And I'll talk about both of them really briefly. On the generative side, we've got everybody's doing a transformer now. Everything is a transformer, and it's a conditional model that converts some input, typically from a user, into a target artifact. And that target artifact could be words, it could be music, it could be video, it could be images, it could be a lot of stuff. Those are the most common ones people are using right now, but there are lots and lots of things. And the way they work at an abstract level and very quickly is they generate tokens. These systems imagine that the artifacts are built out of little chunks of something that are tokens. And those chunks will be different depending on what medium you're working in. And the way those tokens are related to each other will be different depending on what medium you're working in. But the transformer's job is to predict the next token and the next token and the next token. And it does it by converting embeddings of these tokens through a layer of things. And that's the transformation. That's why they're called transformers, because the embedding gets transformed and transformed and transformed until it becomes a probability distribution that gets sampled, and there's your next token. And this is often done autoregressively, meaning that the token that I'm about to predict is based on the tokens I've already spit out. And I'll have something more to say about that in a minute, but that's generally how these things work. Everybody knows what the user prompting is. You get to put something in there that guides this process of generating tokens. You can describe the picture that you want to see, or query with some question, or even give a whole bunch of information like all the proceedings of ICCC and dump them in there and ask questions about it or whatever. The prompt is how the user kind of guides this process. Because those prompts can be all kinds of different media types and all kinds of different things, and because neural networks don't know what any of that stuff means, that prompt needs to get turned into vectors of numbers, and the embedding does that. Those embedded vectors that are in encodings of the prompt are then used to guide this generative process with conditioning. That is, it steers or affects the probability distribution that's sampled from, so that the things that are sampled more appropriate given the conditioning. Most modern models don't work on tokens explicitly. They work on latent representations of tokens, which means they're compressed and non-interpretable for humans, but they're more efficient. And as a result, the thing that's getting spat out isn't words or pixels or video frames or anything like that, but it's a hidden representation of those things that has to be decoded and turned back into words or pixels or video frames or whatever. And finally, although a lot of these models work autoaggressively, like I said, a lot of them now also use diffusion, or instead use diffusion, which means instead of spitting out tokens, I'm predicting noise that should be subtracted out of a noisy artifact until the artifact isn't noisy anymore. Okay, that's generation at a really quick, hand-wavy, and ridiculously fast pace. Training works like this. We need training data, and we need a pile of it. These models are gigantic. They have billions and billions of parameters, and that means we need lots and lots of training data. And because the models are conditioned models, we not only need lots of examples of the artifacts we're generating, images or music or pictures or whatever. We also need lots and lots of metadata that describes those artifacts in natural language or other ways that can be a proxy for the conditioning that a user will dump into the system so that we can train. So it's tricky to find training data that there's enough of and that has rich enough metadata that we can do what we need to do. But that's the goal. That's the challenge. Because we often work in latent space, we also need to build a model that can figure out what's a good latent space to work in. And that's what this codec does. It has two parts, an encoder and a decoder. And the decoder was the thing we saw a minute ago that turned latents back into actual artifacts. The encoder gets used on this side of things. If we are working in latent space, we have to take our training data and turn it into latent representations so that we can train our model on the latent representations instead of the actual artifacts. And if we're using diffusion, we need to add noise into those latents so that the model can learn to pull the noise out. And once we have all of that, we just, oh, sorry, one more thing I forgot. Because we have this metadata that we're using as a proxy for what the system will see when users prompt, we have to embed that in the same way we will embed user prompts so that we can use that as training guidance. And once we have that, we just train the transformer, right? And to train the transformer, we need all this data properly pre-processed like we just talked about, and we need an objective function that says what it is that's good and what it is that's bad, and a way to measure error for what the system does so that we can reduce that error. In the case of autoregression, that objective function is usually cross entropy, and in the case of diffusion, it's usually squared error. Okay, so that was a huge whirlwind tour of the current state of modern foundation models. And now what I propose to do in my paper, and what I tried to do in my paper, and it's really just a way to begin the conversation, is to look at that through the lens of 4 different frameworks that I am familiar with and like that this community has produced. And I don't have any time to go into that except to tell you that you should go read my paper to see a little bit about these, and then you should go read those papers to see a lot about them and use them as this lens to look at these things. And if you do that, you might see, I think, the same things that I'm seeing, or maybe you won't, and we'll have an argument about it, a friendly argument. This is Wiggins's creative systems framework reduced into one single kind of elegant equation. And you can look at this equation and ask what parts of this equation show up in that foundation model we just looked at. And the answer is a lot of it. For reasons that I'm not going to try to justify right now because I don't have any time. But I tried to do it a little bit in the paper, and I'd like to have a longer paper to do it better. But there's also parts of it that don't show up. And that's at least as interesting as all the parts that do show up, I think. And if you look at how to build a CC system, you can do the same thing. And there's parts that don't show up. And this is a little more recent than Wiggins's, and it gives you a little more nuance about the kind of stuff that's not there. And if you look at the FACE framework, it's a totally different way to look at these systems, and it gives you even more nuance. Gives you a different way to consider, and you can see that parts of the FACE framework do show up in these systems, and you can see a bunch of it that doesn't. The FACE framework is cool too because you can sort of give a characteristic expression that describes a particular system based on what parts of the framework exist there or not. The overbars say those parts are there, but humans were involved. And no overbars say this is automatic. This is what my guess for what the authors of the FACE framework would say. They might not agree with me, but I think this is what they would say. This is yet another way to look at it. It's a spectrum. Am I at 2 minutes yet? 2 minutes. It's a spectrum, and it's easy to argue that we're a long ways down that spectrum with these systems, but that wiggly line is where we are about. We're about there, not to the end yet. The spectrum is from definitely not creative to definitely creative and a bunch of steps along the way. Okay, so the takeaways from this are, for me, that these modern systems are pretty awesome. We all know that, and they do a lot of amazing things, but there's a significant level of stuff they don't do yet that these frameworks expose. And you might say, those are the things we ought to be looking at. And some people might say, well, it's not even interesting that they don't do that because they were never built to do that. They were built to be language models or image models or something. And that's true, but a lot of people are losing the sight of that fact now and jumping right to the fact that they're creative. And I don't think that's entirely true. It's true in some ways, as we saw, and not true in other ways, I think, as we also saw. And I want to just wrap up by responding really quickly with a couple of comments, to a couple of comments that reviewers had for the paper. One of the comments was, this is obvious. I don't know why someone wrote a paper about it. And that's fine. That's a fair argument. I think it's obvious, but I don't know that everybody in this room thinks it's obvious. And I don't know that anybody outside this room thinks it's obvious. So I think it was worth saying as a starting point for having an argument, if for no other reason. Some people complained about a monolithic treatment of AI, like no way that architecture you put up there covers everything. I think it kind of does. And I'll argue with you about that offline. And I'm open to why it doesn't and how to modify it if we need to. One reviewer thought the whole thing was too simplified and compressed and didn't get the job done and needed to be a longer paper. I agree, but it still needed to be said here too. Somebody said you should scrunch all of the general architecture stuff down and basically throw it away. And I violently disagree with that. We need more of it actually to justify all these arguments. And the last one is doesn't treat co-creativity. That's absolutely true. That was out of scope. That needs to be done still. Thank you.
Hi, super interesting. Thank you for opening our conference. From those opportunities that.
Oh, I get a mic. Okay. From all the opportunities that
These? Is that what you mean? Oh, sorry. Just ask your question.
Okay. The stuff that you feel can be applied to Gen AI that hasn't been done properly. What do you think is most exciting?
The most what?
Most exciting, most worth doing.
I don't know about most exciting, but I think the most, I think they're all exciting, but I think the most misunderstood and most necessary one might be the artifact level evaluation stuff. Like you get these models generating pictures or songs or whatever, but they don't have any notion of it's a good song or a good picture. All they have a notion of is, does it kind of fit what the prompt said to do? And everybody assumes that the models are thinking about making a good song, but they're not. They don't even know what it means. And to be fair, that's a really, really hard thing. We don't know how to do it here either, I don't think. Oh, no. Yeah, that's a great point. The loss function tells you that you're going to make something that's very similar to what you've seen before. That's all it tells you. And you assume that what you've seen before is representative of good, then in some sense, you're going to produce something good. But you'll also for sure produce something not creative because the loss function is, well, or I should say minimally creative. The loss function by definition is forcing these models to be as much like the training data as they can be. That's what loss is about. And therefore, they're not going to be so creative, I don't think. By sort of design.
So I'm wondering a couple of things. Oh, sorry. Cool, Mike. I'm wondering a couple of things. One, do you think it's fair to say that a lot of current LLMs, especially the bigger ones, converge toward boringness in a way, like converge toward a previously established standard. They're maximized to do that, and by design, that means they're less likely or even unlikely to deviate significantly the way people do when we deliberately.
I absolutely think that's
Experiment.
fair. I 100% agree with that statement. Yeah, that's
Okay.
kind of what I was trying to say, but you just said it better, actually.
I've seen it in synthetic images because I study deep fakes, and
Yes.
I've seen that same thing happen with faces converging toward a boring average.
Yes,
Uh,
absolutely. And people that don't interact with AI very much, they're really blown away by how good it is. And it is remarkable in a lot of ways. But the more you interact with it, the more it becomes boring
Yeah.
and not interesting.
I also wanted to briefly ask about a couple of slides back, you had this scale of creativity to or non-creativity to creativity.
Yeah.
What is the spacing of the scale?
I don't know. I don't know. The spacing is not defined and probably certainly not linear.
Thank you.
It's just like, here's a scale and these are some signposts along the way. I don't know where they are really.
Thank you.
Right. Thanks, Dan, for the talk. I find it an absolutely important exercise to apply process theories on these models. What I've been wondering about is I feel arguably not all of the frameworks models that you've been presented here are grounded in human psychology, for instance.
That's definitely true.
Now, I wonder what that actually means. For me, it makes the standard that we compare any system against somewhat blurry. What do you think about that?
I'm not sure I understand yet what you're saying.
Well, I kind of wonder what is the theoretical or empirical grounding of each of these frameworks that you've shown? To
Like
me, the grounding, like, where is this coming from? This particular structure, this particular observation, what is some kind of, is there some kind of fundamental thing that holds it all together and says these are, for instance, different representation of the same things from different angles? Are these all different conceptualizations, And if there isn't a thing that's holding them together, isn't that problematic? Is that risky? Does it mean there is no consistent standard that these frameworks express that we actually then evaluate those systems again? Could there be opportunities in that? That's something I'm wondering about.
That's a good question. I don't really have anything smart to say about it right now. The first two are at least grounded in one another because the second one was sort of a go at better operationalizing Wiggins's framework. So they're at least grounded together in that sense. But the other two, I don't think you could say, well, I don't think you can say there's not anything holding them together, but I'm not sure that anybody has said that there is and what it would be either. It's a really interesting question. I would love to hear some thoughts about that too.
Let's have a chat about it later.
Yeah.
I've recently tried a process model coming from psychology and applied that to a computational system. So coming from the other side, happy to share.
That's cool. Yeah. Sorry, Simon.
So Simon, you will have to look for that in the reception and.
Be nice though. Thank you.
And the inventor of the Walker burger. Tony is talking today about quite a similar theme in the sense that Tony is asking that why is what here LLMs are generating now AI swap, whereas because similar things would celebrate CC on that when they turn it on. And Tony, do you need a 2-minute one?
Yes, please. Okay, hello everyone. I want to talk about generative AI and computational creativity as well, very much in the same vein as Dan. I guess I'm very impressed by generative AI. I tend to argue a lot with people who criticize it, often because they have terrible prompts and then they complain about the terrible outputs they get. Let me just frame this a little way. About 100 years ago, in Joyce's book, Portrait of the Artist as a Young Man, he ends the book with Stephen Dedalus going to Britain on a ferry and saying, in his writing, he wants to recreate the consciousness of his race. Very fancy. Then about 50 years after that, Woody Allen, also a Joyce fan, tugged on the same thread and said, I want to recreate the consciousness of my race and mass produce it in plastic. And that's pretty much the difference between computational creativity and generative AI right there. We're both going for this soul of creativity, but we're doing it in different ways with different motives and with different screen effects. Okay, thank you. So I want to talk about this problem that we have with generative AI, which is slop. So humans have a problem with AI. We worry about it taking our jobs and our souls, but AI has a problem with humans too, because incredibly dumb people use it to do stupid things all of the time. And then AI is judged by the efforts of these incredibly stupid people who are very popular on social media. And we call this problem slop. It's a very unusual problem because it's technically brilliant. It just has no value, right? Which is a very unusual thing for us. We never had a slop problem. Why is that? Well, the hard truth is our outputs were never good enough. And with very few exceptions, they never really made consumer-facing products that would take the world by storm, right? So they've never had the penetration into the marketplace. And even if they did, we weren't producing the kind of stuff that people were going to make viral, right? So generative AI, I think, produces boring successes. The successes are very successful, but they're quite boring, as Dan mentioned. Whereas computational creativity, we've always made interesting failures. And our failures are quite interesting, and they continue to be interesting. And I think that is something for us to latch onto as a philosophy, right? Okay. You might be familiar with Shrimp Jesus. I find this hallucinogenic and magnificent and empty all at once. It took me hours to draw my Shrimp Jesus, but AI can do it in seconds, right? It definitely isn't kosher. It's the least kosher thing you can imagine. There's something inauthentic about it, even though technically it's brilliant. If you were to ask Michelangelo to do a Shrimp Jesus, you wouldn't get a better one than you would from generative AI. Yet, I mean, in terms of conceptual blending and visual blending, these are topics that we've looked at for decades in this field. And these models do them naturally without being trained to do so. But there's something profoundly inauthentic and kitschy about them. Kitsch is an interesting concept because it is the progenitor to slop. It's this idea in art that is unrefined and vulgar. It's referential. Here's my version of dogs playing poker. It owes everything to Caravaggio's The Card Sharps. It took me hours to draw. AI could do it in a second. What's the value of it? I got satisfaction out of doing it. There was a certain amount of effort, and it's from effort that we get satisfaction. That's why we get no satisfaction from generative AI when we use it ourselves and when others use it for us. That's not because the technology is bad. The technology is amazing. How we use it is all wrong. Basically, we want to avoid kitsch, and kitsch has this mass-produced, plasticky, inauthentic quality to it that generative AI is being used to generate, but it doesn't have to be used that way. Okay, so we need to take this come to Shrimp Jesus moment that generative AI is having and really face it head on. What can we do? Personally, I think we need to be co-creative with generative AI, but co-creative doesn't mean coming up with good prompts. It means doing hard work. Co-creativity has to be hard, for the human in the loop at least. And if we've got CC systems working with generative AI, then they can be co-creative for us, but we have to put the sweat equity into building the CC part of the system. Okay, so that means we need to stress the 4 R's that I think make computational creativity interesting. That's explicit representation, reasoning over representations, reflection over what is being created, rejection and changing course halfway, and gradual evolution and refinement of the output not one-shot generation. Okay, so that's the general pitch I want to make. Let's make computational creativity hard again is my goal. And the way I do that, if I can get specific about my particular research agenda, I'm interested in comics generation. I use what I would call a glass box approach, and I think this is the benefit of CC. We build glass box systems that produce substandard outputs. Generative AI uses black box systems that produce very polished outputs, and between the two of them, I think we can come up with AI that is better than we have now in either paradigm. In the comics generation that I do, we do multiple levels of semantic representation, and finally we generate an XML representation of the comic, which is then ultimately rendered into the visual textual output. And all of those intermediate representations can be modified and reflected upon and refined and reasoned about and so forth. Hence the glass box nature of generation. And there's a huge amount of sweat equity in this. When I said it should be hard, this system, I would have to admit, it pales in comparison to what generative AI can generate. And when I look at the videos that generative AI can generate, it's very hard to stay motivated. I've put thousands of hours generating thousands of visual assets for this comic book system to use. So when it generates a comic, I feel I partly own the output. You don't own the outputs of generative AI just because you thought up of the prompt Shrimp Jesus. You need to put yourself into your system. Computation creativity systems, the best of them are labors of love, and we need to get back to that, I think, even if we're using generative AI. Now, I want to talk briefly about co-creation using the Marvel method. As a comic fan, I haven't really read them in years, I'm too old, but I generate them now. I used to love them as a kid. The Marvel method was used in the comics I grew up with, the Marvel comics by Stan Lee, Jack Kirby, Steve Ditko, Herb Trimpe, all of the greats. And it was a technique that was foisted upon artists out of necessity. Stan was working on lots of books. They used to call these things books. It's kind of ironic. He was working on lots of books in parallel. So he would have a brief story conference with the artists, and they would spitball a plot in 5 minutes, and then the artists would go off and do almost all of the work. The artists would come back with the rendered comic strip, showing pacing and outlines and blocking and pencils and so forth, and then Stan would look at it and go, "What the hell is this?" And then make up the story on the spot, because he's forgotten what he agreed he was going to do. And I thought that's a great way for LLMs and C systems to interact. Okay, so imagine we have a system for generating the art, the draw first part of the Marvel method. Here's a 4-panel comic of a man in the desert seeing a mirage that cruelly turns into a cactus. We give this to an LLM. We don't give it as a visual. We have an AI system describe it to the LLM in the same way that you have audio descriptions for the blind on DVD movies. The LLM then generates the story to go with the art and the captions so that the two are fully integrated and that the LLM can take advantage of any visual metaphors that are available. I really like this one. The mirage is going, "Happy hour is over, honey." He goes, "Cactus? Oh, that's just cruel." The LLMs, they do have somewhat of a sense of humor. It's not fully refined yet, which is great news for those of us working in the area of humor generation. If you want to shape the message, one of the problems with generative AI is that if you fully automate the pipeline, it generates stuff and sends that into the world that you don't control. I was working on a project where we wanted to have automated interventions in online debates, and we couldn't risk the AI just going off the rails, so to speak. So we used the Marvel method to come up with the structure of the story as a blank comic. And then we had the LLM write the story to suit the shape of our message. And the LLM was able to take sides. So here there's a debate about speed limits, which is a very hot topic in Germany, not everywhere else. And it was able to annotate the captions with interesting facts about speeds and accidents and so forth. So we control the shape of the message. Now, obviously, what we want is for the CC system to do the art generation instead of having a human do it, which means coming up with the XML. So that's what we're doing right now. We have what we call a slapstick grammar for generating the actions of a story. Purely visual storytelling. No events other than what you see and no dialogue, but everything is consistent. Look to the paper for the use of the Markov and Chekhov principles to see how this works. But once you have the slapstick grammar, we have about 1,000 nodes in it so far. A random walk will give you the plot outline, the shape of the plot. Then the LLM takes this and turns it into a story. There's a huge amount of investment going into this. That's the hard part. But when the comics come out the other end, we can genuinely say, I am in this output. I helped create this. I didn't create it. I helped create it. And I think that is the message I want to leave you with. Our CC systems were labors of love, and we shouldn't give that up now that generative AI is available to us. We still need to invest huge amount of sweat equity in our systems. We can't simply turn everything into prompting of complex models. And we can pair these glass box CC systems, which make very interesting mistakes, with these fluent and highly generative black box generative AIs, which almost never make mistakes. The era of the six-fingered protagonist is gone, I think, but they're still a little bland, right? Because they don't have the right sand as grist to make the pearl that we want to come out the other end. So that's my message, that we shouldn't be fighting generative AI, but we should be wrestling it into our systems in ways that take advantage of what we can bring. And I think that is consistent with what Dan was saying, and I will leave it there. Thank you.
Making computational creativity hard.
Who was that guy?
Thanks for a great talk and great shrimp Jesuses. Yeah, so lots of artists would disagree with you that only prompting is somehow facile, because they would take days or even weeks to produce a prompt. And there are artists doing that all over the place, and people even employed by big companies to do prompting. And when you get to that level of prompting, we're talking thousands of words potentially, it kind of feels like prompting is just a new form of programming. And that clearly is true to some extent. So the question is, I guess, do you see a difference between the kind of program we've always done in a programming language where you explicitly say things and you explicitly know when you're handing over control and when you're not? Do you see that as different to really extensive prompting?
Yeah, thanks for that point. It's a valid point. I am skeptical. I mean, I think we are in the age where we program in natural language, and a system like OpenClaw, which I love to tell my students about, is written almost entirely in English. It's heart.md file, it's soul.md file, it's skill.md files. They're all in English. You write them properly and the system works a treat. Of course, you're consuming an enormous number of tokens and you're spending a fortune. And that's not the hard part that I was talking about, your willingness to spend a fortune on tokens. Yes, I think prompt engineering is an art. It's an art I haven't really conquered. When I go back to edit my prompts, I often find really painful spelling mistakes in them. And I was like, how the hell did the AI ever deal with this? So it put up with me, right? It's learned to put up with humans being suboptimal.
All the data's got the same error then.
I'm not a fan of these complicated prompts. Certainly when you get AI to help you do your prompting, it gives you these long prompts. I much prefer short prompts in an old-fashioned workflow where you have lots of interactions with the model and where what we would have considered a CC system architecture is using an LLM as a kind of oracle, polling it many times and using it to judge outputs, refine outputs, and so forth. The idea that it can all be compiled into one uber prompt, I think takes us back to the point that it's just prompting.
But it satisfies the condition of being hard, because it is hard to prompt. You have to do
Well, I think it
hundreds of
tells
iterations.
people, look at me, I've written a great prompt. And there are people who sell prompts, and I'm not convinced yet. I think that we can take our CC algorithms and build LLMs into the workflow, where it's not simply, you said this and I gave you that. Our job is done here, right? We need this feedback. We need reflection, as Raphael would say. We need to say, that's crap, do it again. Or that shrimp, its tail is miserable.
You can prompt for that. That's the thing. You can prompt for the meta level prompting.
Yes, again, I'm not convinced. We could have an argument about this.
We probably will.
Yeah.
I look forward to it.
Hi, I have a question regarding slop and kitsch. Some people make an argument that there is space for kitsch because it's already a developed, very profitable kitsch industry around before AI, and that functions very well. And this can just fit into that. I'm just wondering, what is your take on that? Because eventually it's going to probably become part of media history to look at, how people actually started doing slops with AI.
I'm guilty of kitsch all the time. Even this slide here is a knowing reference to Apocalypse Now, right? So all of my slides are somehow referential and borrowed and somehow plasticky, right? They're productified, and I'm okay with that. And I think that CC has been producing a tremendous amount of kitsch itself, because if you look at the rules for kitsch, or how critics have defined kitsch, the use of formulas, the use of tricks, the use of little strategies, that's what we call mere generation, right? And even though we are down on mere generation, we've never really escaped mere generation. What defines us is not our escape of it, but our frowning upon it and our self-hatred for it. So we are kitsch producers as a field. And I think if you were to tell someone this was produced by a computer, the automatic response is it's kitsch, no matter how good it is, because of the stench of mass production that is behind it, right? So no, I am not against kitsch per se. I'm simply saying that this is not a new problem. And Walter Benjamin would have been having nightmares about generative AI, but everything he said is still valid today about mass production and reproduction in the age of art, right? So we just have to live with it. But the point I was making is that in computational creativity, we recognize what we're doing and we try to be better. We have processes, we have internal mechanisms, we have algorithms, we have evaluations. We don't really have that in generative AI. So the solution is not to get rid of generative AI or to say that it's evil and it'll never overtake us, because that's clearly wrong, right? But somehow we need to imbue generative AI with the best of computational creativity.
Thank you.
All right. Hello, everyone. My name is Anna, and today I'm going to talk to you about creative media as seen through the lens of complex systems. And to start you off, I just want to show you something I find quite cool. So this is our place. It was an experiment that was ran on Reddit a couple of years ago. And it's experimental creative media that consists of only 3 affordances that it gives to the user. So it's a collaborative canvas of 1,000 by 1,000 pixels. And it has gives the user the option to pick between 16 colors. And importantly, you have every 5 minutes the chance to select one pixel to change. And then you have to wait another 5 minutes. And despite these very simple affordances, what you see behind me here is something that is obviously very creative and interesting. And even more interesting than this, in my opinion, is the kind of creative processes that are going on behind the scenes. So you have whole communities that are formed for this. People are making factions, they're organizing raids on each other, they're having planning meetings in order to plan the next artifact that they're going to make. And again, all of this is only because of the limited canvas size, the selection of a few colors, and this cooldown timer, how long you have to wait to place the next pixel. So I was talking with my co-writer about this, about how the affordances of the media seems to have this really strong impact on the creative processes that go on that media. And as we were talking, we found ourselves kind of reaching for this toolbox from complex systems in order to describe it. And what I want to try and convince you of in this talk is that actually using formalisms from complex systems is a very useful and natural way to talk about this relationship between the affordances of the media and the creative systems, creative processes, and the creative artifacts that are made. So to start off, some of you might not know exactly what a complex system is. So I'll just say, first off, a complex system is not the same as a complicated system. And in fact, the reason we really like complex systems is because it has the power to make really complex behaviors on a global scale. But in fact, those behaviors are made from very simple rules that are interacting on a smaller scale. And once you have these, for example, in the case of the flocking birds, if you just look at one single bird, it's not very easy to predict how the global shape is going to look like. So, as we like to say, the whole is greater than the sum of its parts. Now, there are a lot of interesting concepts that is very helpful to bring in from complex systems into CC. And I'm going to take you through just 4 of them today and give you some examples of how we can translate this into looking at affordances of the media into the creative processes and artifacts that they produce. The first one I want to look at is criticality. So this is the notion that you have a system that sits between order and disorder. And if you're in strong disorder, you're in a chaotic system, then any small perturbation that you make to the system is going to get washed out in all the noise of the system. Whereas on the opposite side, once you have a very rigid ordered system, any small change you make is not going to have any impact on the rest of the system. And both are kind of boring. But there is a critical point in between where the small perturbations can have these effects that ripple across the entire system. So this was actually the concept that we were reaching for when we were discussing the R place. Because in this case, you have a system where there's one parameter that you can tweak, the cooldown timer, which is how long you have to wait between placing a pixel. And if you tweak that all the way down, let's say to 0 seconds, you end up in a very chaotic state. So any small pixel that you try to add is going to get completely overridden by other uses in like a matter of seconds. But on the other side, if you turn it up to like, let's say, let's wait a year, obviously no one's going to want to use that system and it's boring and stale. But there is this critical point in between, which they seem to have hit on here with the 5-minute wait, where all of these very interesting, rich behaviors are taking place. And again, it's just because in this case, you have this very nice parameter of the cooldown timer. The next concept from complex systems that I want to talk about is path dependence. So this is when you have an exploration space that you only are able to access a small region of it, but where you are able to access is based on all the exploration choices that you made before. So a good example of this you might be familiar with is, in fact, Pick Breeder. So this is where you are presented with some pictures that are a small sliver of the full exploration space available. And you get to combine them in order to explore a slightly different region and explore only locally there. But then you do this step after step. And after a while, you're far into a path. So we get this urge to explore in a pathwise manner to go deeper into the system. But if we didn't have this very local, small sliver of information only, then it wouldn't be interesting to keep pushing through the path. So that's the path dependence. The next concept from complex systems is multi-hierarchy. So this is when you have components that are interacting both on microscale, higher scales, and this can be both in spatial and in temporal scales. So we have an example of this that I like, which is Minecraft. And specifically, this is Minecraft with redstone. So redstone gave users the opportunity to actually couple different elements together in a way that allows the building of automations and machines, which again leads to the creation of factories. You can even build whole computers in there. And someone even made the whole Minecraft engine within Minecraft. So again, we know that without redstone, Minecraft didn't give users the opportunity to make these kind of builds. So the final concept to introduce today is the notion of attractors, and specifically the diversity of attractors. So an attractor is a part in the state space of a system where all the trajectories that you can move through it is kind of dragged towards that point. So it means that if you have a system with only one attractor, then inevitably, no matter what path you take, you're going to end up in that state. So obviously, it's not very good to have a creative system where everything just leads to the same point, right? So a kind of interesting example of this is the generative AI aesthetics. So in theory, the users are presented with a text box where they can add basically any description that they want from the picture. But what results very often is this aesthetic that seems to kind of all be within the same bucket of typical AI aesthetics. So what this kind of tells me from a complex systems perspective is that there is a single aesthetic attractor that is pulling all the artwork towards. So this gets me to the whole point of this presentation. I've kind of introduced you 4 different properties from complex systems, and we've had a look at how that helps us describe the relationship between the affordances of the creative media itself and the creative processes that are going on and what it inspires and lends itself best to. So that also kind of helps to diagnose what is wrong with a system that isn't working. And in the case of the generative AI, what this tells me is, okay, if it only has one aesthetic attractor, then what are the affordances that I can add to the user to enable the creation and the production of more such attractors in the space? So it's on the level of affordances that we want to act. The second thing I want to talk about is, can we use these different properties as a basis to explore the set of all possible creative media that we could potentially make? So we can look at combinations of properties in a creative media, and then we can say, okay, so this fills this space quite nicely, but what are the unexplored regions here? And it would be very cool, I think, if that would inspire some new experimental media. Yeah. Complex, not complicated.
So would you potentially be able to consider a single product of a generative system, a complex system in and of itself? Like, for example, a synthetic image. Each of the components of that image, each of the many, many features that make it up, is integral to creating this image that maybe the sum of those features doesn't equate.
So I would say a complex system needs to be able to interact over time. The parts of the system needs to be able to interact over time in order to be a system in that sense. Yeah, in this case, you have a static artifact, so it doesn't really apply, I think.
Thank you.
Yes?
Thanks, Anne. It was interesting because you were talking both about computational systems, and then it was a very human system that kind of inspired you. I'm just wondering whether there's a different design pattern when we're talking about human-led artifacts rather than complex, like PicBreeder, right? So do you have any reflection on that?
Well, it's a good question. Yeah. So the way I see it, the affordances are always human directed. So even in the case of PicBreeder, then no matter how complex or what the rules are underlying to the system itself, what I want to focus on is what affordances are lending itself to the user. And in this case, it is what can the user see on the screen? Well, it only sees this very limited set of images, which makes it more interesting to try to push out the boundaries and explore further. Yeah.
But you didn't. I wanted you to elaborate it a little bit more if you had a chance.
Okay, so the question was in the sense of the generative AI example with the attractors.
Right, it tends to gravitate to a few canonical.
Right, so it tends to gravitate towards a few canonical artifacts. So I have a theory here, but I don't have an answer. And so as I was saying, the only affordance that the users are presented with in the case of generative AI is the text box, right? So it depends, what do you first think of to put into the text box? Well, it's going to be like, what is the content of the image? I want a cat on roller skates, etc. But there's nothing that really pushes the user to talk about the specific aesthetics that they want. But I believe if there was a user who really was trying to go for a specific aesthetic, then they would push more in the direction, and you actually wouldn't see the AI slop style. So if I was to design a system to kind of try to work with what generative AI gives us, although it is very convergent in itself, then I would maybe add a separate text box that asks, how do you want the aesthetics to look, in order to make the user be aware of this.
So I'm just.
Done. Thank you.